Good morning and welcome to our third session of day 2 of our eHealth Interoperability Days. This session's topic is validation tools and their value for connectivity testing. I am happy to have two experts from IHE-Europe with us, Eric Poiseau and Alexander Berler. Thank you very much for being with us, Eric and Alexander. Before we start, I would like to go over some practical things. Don't hesitate to input your questions online. We will address them at specific points in time. You will receive the presentation by email in the upcoming days. The recording will also be made available in the upcoming weeks. If you would have any remaining question, don't hesitate to join us for our closing Q&A this afternoon at 4 o'clock. And on top, I definitely recommend you to join us tomorrow for our morning session where we have international speakers and our afternoon sessions on HL7 fire in Belgium and mobile health apps and quality criteria. Before we start, we would like to do 2 polls with you. So have you ever participated in connectivity testing? You can vote by just clicking on one of the options. Therefore, we have an idea of who you are. So we have almost everyone that has voted. Please click. You have 2 seconds and we will show you the results. So we have an audience that has not really participated in Connectathons. It's good to know for us. So we will launch a second poll right now. Have you ever used IHE profiles? So click once more. If you can't remember, it's not an issue. So almost everyone has voted. Sarah, you can close the voting and show us the results. So most of the people have not yet implemented any IHE profile. So thank you very much for this. I give now the floor to Eric. Eric,
yes.
if you can share your screen with us. Thank you for being with us.
You should see my screen now.
Yes, we do. The floor is yours, Eric. Thank you.
Alexander, you want to do the introduction?
Yes. Hello from myself as well. I'm Alexander Berler from IHE Services, the director of IHE Services, which is the, let's say, the project office of IHE-Europe. So all the projects and the implementation and all the tooling that we are using also in the Connectathon is more or less managed by IHE Services. So in this session, we are going to present a session about the validation tools for connectivity testing. And in order to do that, we have some introduction slides as an overview about what is a Connectathon and some information about Gazelle. So next slide. So what is important for you to know is that interoperability is a very different animal, and there is a lot of testing that needs to be done. So if we want to enable a proper interoperability integration, we need to start with standards. We need to organize the standards into use cases and then try to validate the specification we create in those use cases in different testing events. Those can be various testing events from Connectathons, which are online events and peer-to-peer testing, in projectathons, which is a very specific set of testing for specifications that are related to a specific project. It can be a national or a regional project. And obviously, there is also a lot of testing in the pre-production phase before all the systems go live. Next slide. So there is quite an intensive testing continuum in interoperability. This can be done at two levels, either at a global scale, which more or less concerns products, or at a local scale, which concerns projects, let's say. So the projects are, let's say, it's a reduction of the overall integration profiles that IHE is using. And IHE is testing those specifications that are created globally through specific technical committees at the IHE Connectathons, which is one of the primary testing events that are happening at least 5 times across the globe, one in Europe and one in the US. That are the two main. Next slide. So just a few words for the Connectathon. So the Connectathon is an open invitation to the vendor community and to the various implementers to test the specifications that IHE International is creating at a global scale. For this, we're using specific test tools that have been developed during time in the last 20 years, and they are still evolving since the use case of interoperability are also evolving. Those testing tools are called Gazelle, and Eric will say quite a lot afterwards. And it's a platform that it's GITB compliant. GITB is the European framework for testing. So it's not only for healthcare, but Gazelle is one of the test tools that has been conforming with that one. So there is a set of monitors that manage the whole process and somehow supervise the peer-to-peer testing and check all the test messages and that are mapped into test plans. Okay, Eric just showed his monitor sheet. And then those tests are passed or failed, and the vendors can see if they need to make some corrections and adjustments during the testing event under the specification. During testing events, we are doing thousands of tests, and we especially during this online Connectathon that is running this week also expect to do quite a lot of testing. And at the end, we record and we publish the results, the successful results. Next slide. So that's just a nutshell what we do. So it's a peer-to-peer testing where each vendor has its own implementations, and through the testing tools, they are able to see each other and make a plan of like a testing matching table. And then they have a list of tests that they have to, during the week, to test against the IHE integration profiles. Next slide. So just a few things concerning the Connectathons. As we said, it's related to use cases. So if you want to create robust specifications for interoperability, you have to split them into use cases. So the use cases then, which are, let's say, business use cases that are provided by the user community, so clinicians that try to explain the basic needs of information exchange they require. Those are, let's say, mapped into the different IHE domains, and from which we create the IHE integration profiles, which are detailed, standard-based set of specifications. Then we bring those integration profiles to the Connectathons, where the participants can have some time and find effort to test it in a peer-to-peer situation. So what we do is not a hackathon, like, for example, what HL7 is doing with the FIRE Connectathons. We are trying to test specification and mature them during those testing events. In order to secure that the testing event is as much successful as possible, the vendors have a pre-Connectathon set of tests so that they can prepare themselves before the testing event. Next slide. So the whole idea is to try to increase the quality in interoperability. So that's why all the integration profiles have a specific set of test plans, and those are known to the participants beforehand. And in order for the participants to be successful, they have to test at least with 3 other parties. The testing, as we already said, is overseen by a set of neutral monitors. So they are not part of the vendor community. There is no conflict of interest there. And all the testing is tracked through the Gazelle test management platform. So that's quite a cultural change that the participants are undergoing during that time, because they have to collaborate with other vendors to succeed, because it's a peer-to-peer testing event. Sometimes they find competitors that are helping them to find and solve technical issues in their implementation so that both of them can succeed the testing. And at the end of the day, this is more effective to comply and to try to address the end customer needs. Next slide. So this year we are in a very specific situation. Usually we do the connectathons on a face-to-face, so it's meeting in a specific place. At least in Europe, it's a different location every year. This year it was supposed to be organized in Brussels, in the Auto World venue. Unfortunately, due to COVID, we had to move this event to an online connectathon event. So that's the first time that we're doing this. And we are reinventing the whole process as we go. So we have quite a lot of vendors that decided to make that new adventure with us. I think it's about 30, 35 vendors that are testing now, with about 45 systems under test. So we have a new set of challenges. We have made adjustments to the Gazelle tooling so that more tests can be done online through the peer-to-peer testing. And we have added video conferencing and chatting tools so that we can somehow simulate the monitor and vendor interaction during the testing process. Let's see how this is going to go through this week. Next slide. So what you need to understand is that Gazelle is the glue to all this ecosystem. The developers, the adopters, and the different reasons to test, the connectathons, the conformity assessment, and the projectathons. Next slide. So Gazelle was created during the process of making those testing events in the last 20 years. And we saw that was necessary to have this set of tools that were necessary during the connectathons as a test management suite. Gazelle is robust enough to be able to manage more than 400 users. That's by the current practice, and potentially it can even handle more than that. It automates the interactions. We can simulate actors and transactions. All this, Eric will go in more details in the next slides. And we create test plans within the testing platform that map exactly the IHE integration profiles and the specifications. As IHE services, we provide stable maintenance to those tools with by providing every 2 years, 2 times a year, a revised version of the tools after each major testing event. So Gazelle is also an ecosystem of tools. Next slide. And this is, you can see this here. So Gazelle is an open source platform. We are reusing different tools, also connecting with authoring tools so that specification can be inserted into Gazelle as seamlessly as possible. And we are trying to map, to find all necessary tools in the open source domain that we can integrate into Gazelle. So we have already integrated several sets of tools from Continuum Health Alliance, from NIST in the US. We are currently working on integrating Inferno testing tools for fire, and many more are also on the way. Next slide.
That's where we switch.
I think that's your turn, Eric.
Yes, before I will enter into my slides, we have 2 polls to go. So the first one is, what is Gazelle? So you have a different choice.
We have half of the people that have voted. You still get 2 seconds before we close the polling. Last chance to click. Showing the results.
Okay, seems like you did a good job.
Yeah, it seems that I passed the message. That's good.
Okay, next poll is interoperability testing is it part of your daily activity? Is an objective? Is a growl? I mean, something like unreachable, or you don't even know what interoperability is?
Let's go and click. It's a final poll for today. So we're almost there. I'm going to close it right now. If you want to vote, click now.
Okay, so it's an objective for most of you, and we have a few who don't know what interoperability is. So then let's start. Okay. So I want to introduce myself first. So I've been the IHE-Europe technical project manager for the last 20 years, and the first time I had to organize the Connectathon in Europe was in 2000 or 2001, and we had 20 person in a classroom, and we were using spreadsheets and Word document to manage the testing, and it appeared that this was not usable if we were scaling up. And for the second Connectathon, we had about 100% participating, and Word and Excel was out of question to manage this testing. So that's where we started, and now we have a platform of tests which has more than 14 years of development. I've been through JBoss 4, 5, 7, so it's based on Java. There are more than 40 Connectathon and Projectathon that have been used using this tool all over the world. We have more than 2 million lines of code, and IHE has invested more than 100 full-time equivalent person time. And so like Alexander said, we are able to manage events like Connectathon with more than 400 person testing together. We have a large community of vendors that have been using it. We have a lot of test cases. We have a lot of users, and we've been doing CDA validation, test instance verification in large numbers. So it's a kind of tool that has made this proof that has been used a lot, and you see in the slides the logos and the places where we have Gazelle instances that have been installed. It's for national IHE, but it's also for company, it's for regional project, and it's also for organizations like I'm thinking about the French blood transfusion. I mean, people who need to deploy interoperability, we need to test it, usually are interested in using Gazelle for testing that. So what is Gazelle? Gazelle is a test management tool that is oriented toward the interoperability and the conformance testing. And interoperability and conformance are really two different things. So in IHE Gazelle, you will find some actor simulators that will simulate the partners, and conformance checking tools that will validate messages. We also have a suite of tools for supporting testing, like data generation and automate for speeding up the testing. So in the Gazelle architecture, you will find some validation tools, and I am giving some example like HL7 V2 validator, we have FHIR validators, we have CTA document validator, we have audit message validators, DICOM validators. We have simulators. So simulators are very useful to find a virtual partner you can test with. And the advantage of the simulator is you can generate error cases, or you can test error cases with simulators. I mean, it's mostly difficult to ask a real system to generate erroneous messages. So using simulator, you can do that. So we have a simulator, which is patient manager simulator, that simulates profiles around patient management, some about ordering for lab, radiology, domain, and cardiology. And we have Gazelle security suites, which allows you to simulate partners for testing the TLS or the exchange of certificate, the unchecks, and check error cases. And we have also XDS tools, which is developed by the NIST, that is integrated. We also have supporting tools, and we will see all of them in details, like a proxy to capture messages, a sharing value set simulator, a demographic data supplier. We have a Connectathon test management tool, and we have a conformity assessment testing. So what is the architecture? So like I said, we have a setters tool for testing the interoperability that is targeted for the IHE Connectathon. That was the first use, but it's also targeted for vendors implementing eHealth standards. So as a vendor, when I develop my product and I need to test the integration, the interoperability, I can use Gazelle tools. And that's why we developed this. That was one of the objectives. The third objective target was for users, especially hospitals. When they get new product, new versions, they would like to test them and organize test session, and they could use Gazelle for that. And we've been in contact with hospitals, and some of them are using it for this purpose. And also for conformity assessment testing, it means you have a need for labeling or certifying product. You could use Gazelle in terms of a tool for conformity checking. So historically, it was developed in REN. It started first with some PHP script and database, and then there was a second generation when I integrated in RIA, and we moved from me, myself, and I alone with a team of 6 persons. And since 2011, this is now developed at Kereval, a small company in REN. So with Gazelle, we aimed at testing interoperability and conformance testing. So during the poll, we had some people who didn't know what interoperability testing is. So if we have 2 systems from 2 different vendors and they need to exchange messages, we expect that the message sent from vendor A to vendor B is understood correctly by vendor B. And if there is a clear understanding and the response is coherent with the question or the message sent, then we have interoperability. We may reach interoperability even if we are not fully conformant. So, for example, today I'm trying to speak to you in English. This is the English standard is, I would say, the Oxford British English. I'm clearly not speaking the Oxford British English, but I expect that you understand what I'm saying. So we have reached interoperability. Also, I may do some syntax error, some syntactic language error, and I'm not conformant to the Oxford English. So in order to increase the interoperability and my communication to you, I can improve my language by being corrected for errors. So that's taking my message, getting it through validation tool and telling me, oh, you do some error here. Or it's also getting from your response some conformance checking. So conformance testing is helping to reach interoperability. And if we have failure in conformance, we may end up into interoperability issue. So that's why we have validation tools to test conformance and simulator to mimic the missing partner so that you can test with a simulator for interoperability. All the tools we have developed in the Gazelle project have been developed in a 3-tier model, in a way that we have tried to isolate the logic from the model from the data. And why we did that is that testing is usually dependent on the specification, the standards, the use case defined by IHE in the technical framework. So that's where we have models. For example, when you specified an IHE profile for patient demographic query, we have defined an HL7 message, and that HL7 message is defined by a profile. Now, when we apply this testing in a specific context, the value to be used, the context in which we use the messages, in which we deploy it, depend on the specific context. And the value set, the codes that are used in Belgium, are different from the codes that are used in Germany or in France or in the US. So we wanted to have our validators, simulators, and test management tools, which implement the logic, to depend on models that contains the specification and can be deployed in different contexts depending on the data set that are used where they are deployed. So if we look at the conformance checking tools, this is to check the validity of the exchange message. The goal of this tools, all the tools that we have developed for conformity checking, is to verify that the message and documents that are exchanged are conform with the specification provided by the standards and IHE. The target, who are the users of these tools? So we have developers, application developers, testers, but also simulators. So when we develop simulators in Gazelles and we receive messages, we want to be able to validate the messages that we receive or that we are generating to make sure they are conformant with the specification. So that way, we have the general model for the conformance checking tool. So we have the information model, which can be CDA document definition in RDecor or HL7 v2 message definition or FHIR specifications. We have value sets, which are to be used in the context. And we have the logic that is taking the input messages and check with the information model and the value set that they are coherent. In terms of interfaces, we have two types of interface. We have a GUI, so that the user can interact with the validator. But we have also a socket, which is a web service, so that the tool can interact with the validator. So in terms of validation tools, we have validation tools for CDA documents. It's called Gazelle Object Checker. We have for V2 messages, V3 messages, FHIR messages, all the XDS suite of messages for sharing value set, for the workflow documents, for audit messages, for certificates, for SIML assertion, etc., etc. So there are many, many, many tools. And in order to simplify things for users, when I mean humans, we have developed an application which is EVS client, which provides a front end to a user so that he can call the validation tools from a web GUI. I provide here a link to a video that describes how to use the tool. So you'll get the slide and you'll be able to watch it offline. We don't have the time right now. But I'm showing you some slides of the GUI. So for example, here we are in the context of CDA document validation. And you see that you can validate documents or messages in the context of IHE or EPSOS project or other project. And we have different implementation in a different project with different context. And here you upload your document. You say you want to use the schematron or the model-based validator. And once you have performed the click on the validate button, you get to the outcome of the validation, where you have the outcome of the validation. So the document was XML valid, the schema validation passed and the model-based validation failed. And here you have the details of the errors with the tree of the templates in the CDA document. So if you don't know CDA document, don't worry, but we provide hints on where the errors are located in your document. And we try to point to where, you see here, click here to view the OCL assertion. So we describe what is the reason of the error, and that way we can point to entries that point to the specifications, so that you get an hint from where the error is coming. And using this kind of validation tools, providing the users the right feedback on why and there is an error and where it's coming from, we've saved a lot of times in our supports, because we didn't have to explain why the error is coming from. And in some cases, you get the standards, you get the IHE specification using the standard, and then you get the regional specification using the IHE profile. And sometimes you get some contradictory constraints on the messages, and by identifying where it's coming from, you can help identifying the issues. And I can give you an example. For the EPSOS project, we had constraints that were specified by EPSOS that were not consistent with other constraints from CDA, and they were not compatible. And sometimes we were fixing an error in the validation tool because people were saying, "You're wrong here," and then we were getting another error because there were two contradictory specifications. So that's about the validator. Then we have simulators. And the objective of the simulators is to test the interoperability of an application. You have to understand that the simulator is not a reference implementation. There is no way you could use one of our simulator on production, because we are not implementing the core business of the product, but we are only implementing the interfacing. So what's coming in and what's coming out. The advantage of using a simulator is that you get a controlled test environment. So you can exactly know what's coming in and generate error cases you should be able to respond. So the target of the simulator is for developers, but also for testers. In development phase, I've got quite a few number of people that are using the simulators in order to get an hint on how to generate the messages, what should be the content of the messages, what it will look like. So they use the simulator to as an indicator or as a learning phase. So the global interfacing for the simulator is like for the validator. So we have a graphic user interface for a human to interact with the simulator. So the human will interact with the simulator and with the device or the application he wants to use for the testing. In the simulator, we'll find some link to the value sets, to the validation tools, and to the information model in order to generate the messages that have to be created by the simulator. And there is also a socket interface that depends on the type of simulated message, so that the tested application can interact directly with the simulator. So if we look at an example of a simulator, this is, and you realize here that this is not a real application, because this is really for testing purposes. So here it's for testing XDS transaction, which is called provide and register set B. And you have a sequence diagram that shows what is going to happen. So you have the simulator that is named simulator XDR, and you have a system on the test, which I've selected here in a different GUI. And I can elaborate my submission set by giving the patient ID, by adding some metadata. I can even add some of the optional metadata. And you see here in the pickup list, we point to value sets that corresponds to the context or the affinity domain in which we have implemented or deployed the simulator. So basically, this simulator for XDS can be deployed in a context for Germany, for France, for Italy, for British. You just need to differentiate the value sets to be used in the setup where you are installing it. So we have simulators for XDS, for order management, radiology, laboratory, cardiology, eye care, for patient management, for sharing value set, and for security. I will not go into the details now for these simulators. Concerning test management tool, the objective is to be able to manage an event like a Connectathon and also Projectathon. So in a Connectathon, we add up to 160 systems tested together in one room. So what you need to know is you need to register this system. And so when people register the system, the tool will tell what to test. So the vendor registers the system. They tell my system is implementing this actor and this profile. And based on that, the tool is elaborating the test plan and will find for you the list of possible partners during the Connectathon. So we provide a list of tests to be performed to the participants. And there are two kinds of tests. There are conformance testing tests. There are tests that are to be executed before meeting the actual partners. And we are using the simulators and the validators. And we do interoperability testing, which are used and tested during the Connectathon and are system to system. So by having the conformance testing run before the actual event, the participants can actually be more prepared and diagnose errors in their system before they actually test with actual partners. And by implementing this conformance testing, we have improved the quality of the testing we have been doing in the Connectathon. So after that. So if we look at the architecture and how it's organized, so if I've got one vendor on the left managing his system, another vendor on the right managing his own system, each of them will be able to get their test plan, find the test partner. They will be able to log evidence on the testing they are performing and get a test report for the testing they have been performing. Each system manager interacts with his own system, and we get exchange messages between the two participating systems here. So Gazelle will play the role of a speed dating tool in order for each of them to find themselves on the Connectathon floor or online, saying, okay, I want to start a test with you. I want to test this test instance, and let's do it now. Are you ready? What is your configuration? What is your IP address? What is your port number? What is your AE title, etc., etc. They perform the test. They log evidence into the Gazelle tool, and then a monitor can look at the test management, find the tests that are completed, look at the evidence, and verify that the test was performed correctly and in adequation with the test plan. What you see also here is that we use value set for the test description. We have our test plan, and we have the technical framework model that are embedded in that are different modules. And so we can use different technical framework models. So that means it's not bound to IHE, and it can be used in a different domain. And for example, we had when we were in Rotterdam for the Connectathon in Den Haag for the Dutch Connectathon, we had people from Austria testing connectivity between electricity network. Over the years, we have improved this first concept by adding a proxy. So we allow people that are testing at the Connectathon to use the proxy in between them to capture the messages. So that way, it's easier to log the evidence for the test instance, because when people start their test, they can point to the proxy and get the link to the messages that have been exchanged between the two partners. And since we have the actual messages captured and we know how they're captured, we can use validation tool and use the validator I've described earlier. So as you see, we have built a set of tools that are very modular and that can be combined in different ways. So this is the overview of the different components that we have. This may not be up to date, but it doesn't matter. What I would like to show here is that if we look at the Gazelle test management tool or at the patient simulator or the lab simulator, you see that there are components that are reused, like the demographic data server that can be used to generate demographic data on the demand for the purpose of testing, or some validation service that can be used in all of these tools. So I can go in further details into some of the validation tools. I've already shown this slide, but if I look at the HL7 V2 validation tools, so we have a validator. So it's a service that can be called, and like I want to give you details on how it's working. So like I said, we have a definition of the specification. So in that link, you have an XML expression. I hope you see my screen. So this is the message profile definition that explain what we expect in the HL7 V2 message. And that is an XML message. Let me show view page source content. This is an XML content, and what you are seeing here is the XML content with a style sheet. So we have expressed the content of the technical framework into an XML structure. I mean, we have not invented anything here. This is a definition, a format that is provided by HL7. But we feed that to the tool. So the validator is using that as a reference on how to validate the message. Into that, into that definition, we use, for example, some tables, and we say the values are coming from these tables. And I talk about value set or data. These are specific to the context where we deploy. And we have also here in XML the access to all the tables that are coming from HL7 or IHE or the region or the context of the deployment. So for example, I can look at the religion table, I can look at the race table. This is the values that the tool will check for valid data. So if you want to add in your context some specific data, you can add them in the table, and the validator will take them into account. And finally, we use some authoring tool to generate this XML document I showed you before. Before we used messaging workbench, now we are using the IGAM tool from NIST. Same thing for audit messages. We have the definition of the audit messages in the Gazelle security suite. So audit messages are traces that are sent in order to respond to the requirement in terms of security, so that we can do some a posteriori tracking of deviant comportment or behavior in the system. So we provide an authoring tool and a service for validation. And you have the link and you will be able to visit and look at it offline. If I want to go for the simulator and an overview, some interesting simulators are the patient manager, and the patient manager is for all the profiles that are related to patient management, the order manager and the Gazelle security suite and the XDS tools. So you get the links to the tools. So if I go to the patient manager, it mimics, I mean, it can implement PICS and PDQ, V2, V3, and PAM and XCPD. So for the FIRE profile, it does for SD 2, 3, 4, and future ones. I mean, each time there is a new release, a new version, we need to update it. And it also contains some automation. For example, this was a work we did with Interop Santé in France, and they have, for the PAM profile, define what are the possible status of the encounter of the patient. So you can be extern, you can be in emergency, you can be hospitalized, pre-admission so there are different states, and they have the different trigger between this message. And you can enter that into a GraphML format into the tool, and then the tool will generate messages in a coherent manner, and to make sure that your application can handle all the cases. So that way you can do some automation, and that's an example I wanted to give you. So in order to simulate this, we had about 380 messages that need to be sent in order to visit all the ages. So that can be fully automaticated and can be used, for example, in a continuous integration environment for implementers. If we look at the Gazelle security suites, it generates signature and certificate for testing purpose. So it plays the role of a certificate authority. And also it can generate messages, for example, to make sure that you handle the error case correctly. So you can initiate with the tool some TLS connection with an expired certificate, an invalid certificate, all kind of error cases. And it supports different protocol. So sometimes when your developer needs to implement that, they need to learn a lot about security, and it's quite cumbersome to generate this test cases. And with that, we have a common set of framework for people to use and to implement. For the XDS, we are using two sets of tools. The set of tools developed by the NIST and the one that have been developed by Kereval for IHE, which is XD Star Client. They both are complementary, and you'll find things in the NIST tool that you cannot find in there, and vice versa. So we did it because we were having some missing part in there. We also have tools for supporting testing. So I mentioned them in the introduction, and I will go quickly over them. So the Gazelle Proxy, which plays the role of the man of the middle and can capture messages exchanged between two participants to a testing session. We have the sharing value set simulator, which contains the coded value, and it provides a GUI that that can be used to view validation value sets and enter them. We have the demographic data server, which is an application that allows you to generate fake patient data on the demand. My experience was that people were using always the same values. So if we look at the tool, you can create a patient, and you say, I want to create a patient for Belgium. You say generate demographic data. Oops, and this is the demo effect. But it should create data for Belgium. So this provides also web service interface so that you can generate data on demand. We have also an assertion manager to manage the assertion tested in the test cases. So let me go back to my slides. Okay, so what I mentioned at the beginning in the introduction is that this can be used by developers, and I will show a slide that is coming from the EPSOS project, but that illustrates how it's used by some of the vendor community to do some internal testing in terms of CI, continuous integration. So basically what they want is that when the developers are writing new lines of code and they commit their sources into their source repository, GitHub, GitLab, or their Forge, each time there is a commit, there is the good practice is that you run some test cases to make sure you have not broken anything with these new lines of codes that you've written. And people are using our tools, our validation tools, for continuous integration. That means each night, when they have new commits, they will call our validation tools to make sure that they have not broken anything into their applications by the new lines of code. So that's something available. So far, it's free to use. I mean, it's not, there's no charge to use for it. It's service provided as it is. But I think it's valuable for the industry to use. And finally, because I think I need to conclude, this is the wrong set of slides. But what I want to emphasize is that I encourage you to integrate interoperability at the early stage in your development. And with all these tools, you have the ability to test them, to use them in order to test interoperability at the earlier stage of your development. But usually people think of regulatory aspects when they are designing their project early in the phase of the design, and they forget the interoperability aspects. And at the Connectathon, I've met many vendors who are coming because they are discovering interoperability at the late stage. And the answer to the poll we had at the beginning of this presentation is, I mean, is symptomatic. I mean, there are people saying, I don't know what interoperability means. So interoperability should be earlier in the design of your product. It has to be there from the early stage so that you can design your product in a way that changes in specification for interoperability or API of your partners will not impact the design of your product, will not impact the CE marking of your product as well. So Thank you. That's finishing my slides now. Hope you have questions. So, Caroline, I let you manage the questions.
So you are all unmuted. If you want, you can speak up right now, because we have not received any questions in our questions section. So go ahead while Eric and Alexander are still here. Don't hesitate. Raise your hand, speak up. So
If you're not comfortable to speak up, you can write the question in the chat and we'll read it.
yeah, sure, but we have not received any questions up until now. So I think we can finish this session. Thank you very much for joining. Thank you, Eric, for sharing your knowledge with us. Thank you, Alexander. I hope to see you all tomorrow or this afternoon for our Brussels eHealth Network sessions. Have a good day and take care. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank you.
Bye.
Thank you.